Now let's look at the number 7. And first, let's rewrite this 11 pi over 6 as the 6 plus 5 times pi over 6. You divide 11 by 6. The quotient is equal to 1 and the remainder is equal to 5. So this guy is equal to pi plus 5 pi over 6. And if you sketch this angle, we have the angle like this. So first, we have the pi here, and then followed by the 5 pi over 6. So 5 pi over 6 right here. So this is the 11 pi over 6. Then the reference angle theta prime is equal to 2 pi minus this 11 pi over 6, and you get pi over 6. Then in the quadrant 4, cosine is positive. So cosine of the 11 pi over 6 is equal to cosine of the pi over 6, and this is equal to root of 3 over 2. Now let's look at the problem 8. We need to find the sine alpha if we know cosine alpha is equal to negative 3 over 5 and alpha is in the quadrant 3. So it's page 445, and this is the pop quiz from 8. And we know the cosine alpha equal to negative 3 over 5, and alpha is in the quadrant 3. So now we need to find the sine alpha. We know we have the fundamental identity, which is the sine square alpha plus cosine square alpha equal to 1. And from here we have the sine alpha equal to plus minus the square root of 1 minus cosine square alpha. And in the quadrant 3, sine alpha is negative, so we take the negative sign. We have the sine alpha equal to negative square root of 1 minus cosine square alpha, and this is equal to 1 minus the square of the negative 3 over 5 and then square, and this is equal to negative square root of 1 minus 9 over 25, and this is equal to 25 minus 9 over 25, and then take the square root, and this is equal to negative square root of 16 over the 25, and finally you get negative 4 over 5. Now let's look at the section 5.3, page 463, and let's look at the problem 1 of the pop quiz. Determine the amplitude, period, and phase shift for this function. Pop quiz of the section 5.3 is page 463. Number 1, we have such function y equal to negative 5 times sine of 2x plus 2 pi over 3. So first, we try to find the amplitude. The amplitude A is equal to the x value of the coefficient of the sine function. So that is x value of 5, so which is equal to 5. And the period P is equal to 2 pi, which is the period of the sine of x, divided by the coefficient of this x. So divided by 2, then we get pi. To find the phase shift of this function, we need to rewrite this function in such standard form. So first, we factor out this 2, and then rewrite this as minus of negative pi over 3. Then this negative pi over 3 is the phase shift. Now next to the number 2, list the coordinates for the 5 key points for one cycle of the y equal to 3 times sine of 2x. Number 2, we have function y equal to 3 times sine of 2x. We know the 5 key points for the sine of x is like this: 0, 0, half pi, 1, pi, 0, 3 pi over 2, negative 1, and then 2 pi, 0. To get the 5 key points for this function, we may just set 2x equal to the x coordinate of the 5 key points of the y equal to sine of x. So set this 2x equal to 0, half pi, pi, 3 pi over 2, and 2 pi. Then we get the x coordinates of the 5 key points of this y equal to 3 times sine of 2x. So we got x equal to 0, pi over 4, half pi, 3 pi over 4, and then pi. And corresponding to this x coordinates, we have the same corresponding y coordinates. So we can form the 5 key points for this y equal to 3 times sine of 2x. So x is equal to 0. The corresponding y value is equal to 0 times 3. So you have the 0, 0. And when the x is equal to pi over 4, 2x is equal to pi over 2. Sine of pi over 2 is equal to 1. And 1 times 3, you got a 3. So pi over 4 and 3. And when x is equal to pi over 2, 2 times x is equal to pi. And sine of pi is equal to 0. And 0 times 3, you got a 0. And when x is equal to 3 pi over 4, 2x is equal to 3 pi over 2. Sine of the 3 pi over 2 is equal to negative 1. Negative 1 times 3, you get negative 3. And when the x is equal to pi, 2x is equal to 2 pi. sine of 2 pi is equal to 0, and 0 times 3 equal to 0. So in this way, we get this 5 key points.